Hello everyone, this is Chem Math and a little bit of intro to the channel. I already did uploaded one video for the channel introduction yesterday, but I think I will be giving a very short introduction to you right now. So this channel is all about chemistry and maths of high school and senior high school level, along with chemistry of UG and PG level, and very soon we will be adding UG and PG level biochemistry also, and that will also cover the basic concepts of bio plus biochemistry. So if you have to follow this channel, I would suggest you to learn by heart what is taught. Try to understand it, take the notes, and just keep learning, because this is totally based on the concepts from various NCERT from the NCERT book, sorry, and various reference books, along with some information from the AI. So it is altogether everything that is needed for a particular topic. So you don't need to go anywhere extra. You can just do questions from the reference books after studying from here. So uh, the concepts are really great if you try to learn them, and all the best for that. So, today we are starting with structure of atom. This is the second unit of class 11th, and today we'll be covering atomic models and atom representation. So we will be studying about different models of the atom. Those were discussed by different scientists like J.J. Thomson, Rutherford, etc. Today we will not be doing the Bohr model because we have to study few concepts before that. So there will be a separate video for Bohr concept theory. Then and there are few terms and few questions that I will be discussing. And yeah, one more thing, that in case if someone like wants a particular chapter to be done first, either it is from maths or chemistry, you can let me know. We will make a video over that first. Okay. So for now, let's dive into this chapter. Okay. So all the best. Okay. So first, the introduction part of the chapter. So what happened that when atom was discovered, it was named as, like, the building block of everything. Any species that was seen out there, they told that atom is just the building block of it, and there can't be anything smaller than that. So it was considered to be non-divisible. So as the first point says, that earlier it was believed that atom is non-divisible. Then what happened that some scientists carried out some experiments which are given in the NCERT book. Those experiments are cathode ray experiments, anode ray experiments. But okay, so those experiments actually I haven't put in this video. I will be creating a separate video at the end of the chapter because they are not very important, because they only actually discovered electron, proton, neutron, and we need to know like who discovered what, like the name of the scientist, like how the experiment was carried out. That is none of our business because it is never asked in the question, in the paper, sorry. And also, like, why do we need to know all that stuff when we can actually apply the findings of those experiments, right? So still I will be creating video because it's not that important topic, so I will be doing at the end of the chapter because this chapter contains a bunk of knowledge and I need to focus on that first. So then what happened that electron, protons, and neutrons were found. Like right now, there are n number of atomic particles, subatomic particles, which are discovered, but we study electron, protons, and neutrons only. So during the end of 19th and beginning of 20th century, it was established that atoms can be divided into subatomic particles. So on the basis of those experiments, there were subatomic particles which were discovered, and hence it was said that atom can be divided. It is divisible, and it consists of subatomic particles. So now, there was this question that atom in itself is very small. Now, it contains some species, and also atom is neutral. Then, how are these positively charged and negatively charged species are arranged in the atom so that it is neutral? So this was the biggest question at that time. So what happened that after that, like many models came that we are going to discuss. So let's move on to the next slide. And there were a few scientists, like those who explained and proposed those atomic models, and we will be discussing that. Now, look at this table, please. There are these three species: electron, proton, and neutron. You need not to learn anything from this table, but just keep in mind the symbol EPN, the relative charge, -1, +1, 0. This is very basic, so everyone knows, I guess. And yeah, approximate mass in atomic mass unit, that is 0, 1, and 1. So the approximate mass is 0, 1, and 1 for your electron, proton, and neutron. Okay, these absolute charge and mass per kg you need not to learn, because these values are given in questions in case you get any question. Okay, so for now, just learn the things that I told you. Okay, we are moving to the next slide now. Okay, so first model that we are going to discuss is Thomson model. It is also known as plum pudding model. And now, what J.J. Thomson said is that firstly he stated that atom is sphere. Okay, uh, everyone almost agreed that okay, fine, atom is a sphere. Now, how can you explain that? How it is neutral, and how are the positive and negative charge species are arranged? So, what he said, Thomson said that the positive charge is actually uniform throughout that sphere, and is actually means responsible for the mass of that species, while the negative charge is embedded in that positive charge. For example, the plum pudding model, it is said because for example, you have a pudding and you have raisins in it on the top of it. How are the raisins embedded in the yellow part of the pudding, right? Like randomly anywhere. So similarly, you told. Now you can also take the example of this watermelon, which I have attached over here. These black seeds are the electrons, and this red part is the positive charge. Now, you know, if you are a science student, everyone knows that positive and negative are two opposite charges and they attract. If they attract, they will combine and they will neutralize each other. So पहले ही दिमाग में आ जाता है like how is this possible? Okay, so this was the major drawback of his model, and it was the that's why neglected. Okay, and you can see the last point I have very nicely written that model also couldn't adequately explain the stability of atom. Like obviously it will not be stable. Like you are saying that the negative charge is there and the positive charge it is embedded there, and why is it not neutralizing it, right? So how is this possible? Atom will not be stable. So this model was that's why neglected, and we need not to waste much of our time over this topic. Yeah, another major drawback was that he believed that positive charge is uniformly distributed. Okay, so we haven't studied the Rutherford model yet. Yeah, but I must tell you that Rutherford did an experiment, famous experiment, alpha particle scattering experiment, and he found out that atom was actually 99% vacant. So now he did the experiment, and experiment, and it's like we believe more on experiments than what is said sometimes. Like Thomson just gave the statements out of nowhere, while Rutherford did the experiments, so we actually had to believe Rutherford. So that's why Thomson's model was neglected, and okay, now we are moving to the next slide where we will be studying Rutherford model. Okay, so this was the setup that you can see in the image of the Rutherford's experiment. This experiment is also known as alpha particle scattering experiment. There's images from NCERT, and okay, so this the box kind of thing that you are seeing here is the generator of the alpha particles. This is the source of the alpha particle. It is radioactive. This plate kind of thing here is lead plate. It was used so that there are actually so many other kind of radiations and so many external factors. We need not to get them into our experiments. So this plate was used. Now this round kind of thing is your detector. Whenever any alpha particle actually struck this thing, there was a flash, which was recorded. And this golden thing is a gold foil. It was really, really thin, and yeah, so this was the setup. Okay, so you can explain the setup along with these points that I have written over here. Note them down, learn them, and there is nothing much to be studied over here. I have explained the like use and purpose of this, all the things that are used in this setup. So you just note them down and learn them. Okay, so let's repeat once again if you want. This box kind of thing was your source of vapor particles, it was radioactive, and your this plate was your lead plate. Why was it used? This was used to shield the apparatus from external forces. There was used a gold foil through which alpha particles were passed, and this round thing was the detector, and this detector was made of fluorescent zinc sulfide, and whenever an alpha particle struck the screen, tiny flash of light was produced at that point, which was later on recorded. Okay, now we will be now moving on to the findings of the Rutherford's experiment on the next slide. Okay. Okay, so let's discuss now the observations and results of the Rutherford experiment. The first thing that we are going to discuss is the observations. The first thing that Rutherford noticed that uh, most of the alpha particles actually pass through the gold foil. So, what does this suggest? For example, there is a window, and you are throwing, a cup of water from it. If it is open, whole of the water will pass through that window. Okay, so this point also suggests that this atom was empty. Most part of the atom was empty. Then what happened that there was a small fraction of the alpha particles that was deflected by small angles, showing the deflection must be due to enormous repulsive forces, showing that the positive charge of the atom is not spread throughout and is concentrated in a very small volume. Now, a very small fraction of alpha particles, what happened that they were being deflected by some angle. Okay, and now alpha particles, if they are deflected, now if alpha particles are positively charged, if they are deflected means they are deflected by some positive charge. So the positive charge, as we know, the nucleus of the atom contain nucleus contains protons and neutrons. Okay, we are again discussing this thing also in the future slides, but still remember that a nucleus contains your neutrons and protons are positively charged. Okay, so alpha particles were being actually deflected by these species, and since uh, there was actually a very you know small angle of deflection, so this shows that this nucleus, which had that positive charge, was not spread throughout but was concentrated somewhere inside the atom. ओके, अगर वो पूरा फैला हुआ होता है एटम के अंदर, तो हमारे अल्फा पार्टिकल्स तो पास ही नहीं होते। ओके, गुड फॉइल से वो पहले ही डिफ्लेक्ट हो जाते, बट दे वर पासिंग ऑल्सो। वो पास हो रहे थे, इसका मतलब दैट इट हैड एम्प्टी स्पेसेस, लेकिन थोड़े से पार्टिकल्स डिफ्लेक्ट हो रहे थे। दिस मीन्स दैट there is some positive charge somewhere, but it is not spread but is concentrated somewhere inside the atom. Now, there was one another proof that there were very very few particles, like 1 in 20,000, that was deflected by an angle of 180 degree. that वो अल्फा पार्टिकल गया और वो 180 डिग्री होकर वापस आ गया, वो जिस डायरेक्शन से गया था उसी डायरेक्शन में वापस आ गया, एंड दिस वाज एक्चुअली हैपनिंग एट द सेंटर. ओके, so these were the observations of the Rutherford model, or I must say Rutherford experiment. Also, he did some calculations and he found out that the radius of the atom is actually like 10 to the power minus 10 meter, while that of the nucleus is around 10 to the power minus 15 meter. So, if atom is small, then nucleus is much smaller than that. Okay, the best example for this situation is a cricket ball in a playground of 5 kilometer radius. So, this content of the observations is enough for you guys to study. Don't do anything extra. And now we are going to study the results. Like, what were the results of the Rutherford model of atom? Okay, so these are the results. So first result here that I actually explained you guys that the positive charge is extremely concentrated in a small region, right? And you know the reason behind it. I actually explained in the previous slide, so I'm not going to explain this again. Now, what he did, Rutherford actually, what he did, he said that the nucleus is at the center of the atom and the electrons are actually revolving it. So, like, although the planets revolve in the elliptical orbit now, but still we are taking the example of sun and planets. For example, Earth is revolving around the sun in a circular orbit. So this was what Rutherford explained, that there is this relation between the nucleus and electrons that are inside the atom, and it is quite similar to the planetary motion of the you know planets in our solar system. So this was how he explained. Now this again came with a major drawback. Now when we talk about planets revolving around the sun, we are talking about some macro, species. Macro, they are very high in mass. Their mass is very large, right? Also, they are not having any kind of charge over them. Okay, so they can revolve. There are centripetal forces, right? But when we talk about microspecies like electrons and nucleus, they are actually charged species, and there are attractive forces inside them. Okay, so he was unable to explain that while revolving around the nucleus, why don't these electrons are attracted towards the nucleus, because these are two oppositely charged species. And by the statement that he gave, the electrons should fall into the nucleus and the atom should be unstable. So again, we had to neglect his model, and we need to find some other model that satisfied our needs. So let's move on to the next slide and see what's there to study. So very simple topic. What is atomic number? What is mass number? Okay. So as you can see, you have to note this down and you have to study it on your own. I am explaining it. Atomic number is represented by Z and mass number is represented by A. Okay, so atomic number, although atomic A starts with A, so it is not represented with A, it is represented with Z. Please remember it. Now, atomic number is equals to number of protons and atomic number is equals to number of electrons also. But provided the species is not charged. Okay, if there is a charged species, for example a cation and anion, the number of electrons will change and the atomic number can't rely on number of electrons now. So actual mein atomic number is equals to number of protons. Please remember this thing. Okay, now atomic number, mass number. Now protons and neutrons together are called nucleons. This again is sometimes they ask the question like what are nucleons. Okay, now after that, an atom, it can be represented as X in subscript where write Z and superscript is A. Okay, so mass number is always written as a superscript and atomic number is written as the subscript, and X is the symbol of the element. Now, for example, your sodium atom is there. So the symbol is Na and its number of electrons are 11. Now, since it's a neutral species right now, so number of electrons equals to number of protons. So your atomic number is 11 and mass number is 11 plus 12, because 12 is the number of neutrons in sodium atom. It is stated. I'm not making this up actually. So yeah, you can check the data also. It is stated there are 12 number of neutrons. So this is the symbol that I have written as in the representation part. Okay, let's move to the next slide. Okay, so actually I wanted to explain you few things. Now, this is the number of electron calculations. Okay, so it's very easy. We just have to keep few things in mind. Okay, now positive charge means the electrons are lost. Negative charge means electrons are gained. Okay, these two statements please keep in mind always. These are very helpful. They seem like very easy things, but in your future when you are going for some other chapters, they are very useful. Now, number of electrons is equals to number of protons plus charge if there is a negative species. If there is a For example, why I'm okay. Firstly, why I'm using number of protons in calculation of number of electrons. Now we know that number of electrons is equals to number of protons. We know that. ठीक है, जितने प्रोटॉन होंगे उतने ही इलेक्ट्रॉन होंगे, लेकिन ये कब होता है? ये होता है जब आपकी स्पीशीज न्यूट्रल हो। ठीक है, लेकिन मान लो स्पीशीज पे चार्ज आ गया, तो इलेक्ट्रॉन तो चेंज हो जाएंगे, number of electron will be changed, लेकिन प्रोटॉन सेम रहेगा। एंड विद द हेल्प ऑफ प्रोटॉन एंड विद द हेल्प ऑफ दैट चार्ज वी कैन कैलकुलेट द नंबर ऑफ इलेक्ट्रॉन्स। कुछ नहीं करना है। फॉर एग्जांपल आपके पास देखिए यहाँ पे है O2 माइनस है। ठीक है, आपके पास स्पीशी है एक O2 माइनस। अब ऑक्सीजन के पास प्रोटॉन्स होते हैं 8, उस पे आ गया 2 माइनस का चार्ज, यानी उसमें 2 इलेक्ट्रॉन और आ गए, तो 8 प्लस 2 10। Okay. Similarly, Al3 plus is there. So aluminium number of proton equals to 13. लेकिन there is 3 plus charge, यानी कि 3 electrons are lost. So 13 minus 3, which is equals to 10. Okay. So that is why. That is how we are calculating our things. Okay. Learn these formulas. These are very basic things. I think you need not to learn these things. It's very very easy. Okay. So we will be discussing few terms right now, and the first one is isotopes. So isotopes are nothing. These are the species that have same symbol. Okay, symbol will be same. Their atomic number will be same. Okay, but the thing that will be different is their mass number. Now, since their atomic number is same, यानी कि protons are same, but their mass number is different. Mass number is proton plus neutron. तो difference कहाँ पे आ रहा है? That is neutrons. The number of neutrons are different. Okay, that is why these are the different species. So examples are your hydrogen isotopes. They are protium, deuterium, and tritium, and they are represented as 1H1, 1H2, and 1H3. Okay, and there also have the symbols, different symbols, like for protium it's H only, for deuterium it is capital D, and for tritium it is capital T. And the main difference is, look, the number of protons are similar in all of them, but in protium there is zero number of neutrons, then there is one neutron in deuterium, and there are your in tritium 2 neutrons now. So the mass numbers will be 1, 2, and 3 respectively. Isobars is totally opposite of that. The atomic numbers will be different, but atomic mass will be same. And your symbols are also different, okay? So examples are in front of you: argon, calcium, and sometimes potassium is also considered, okay? So but since argon and calcium is there, I have taken this example from NCERT. So do it also. Yeah, potassium is also there. No worry. Okay. Now isotones. Isotones are the same number of neutrons. The species with the same number of neutrons. Okay. And examples are in front of you. Nitrogen 14, carbon 13 are isotones. Isodifers, your difference of the number of neutrons and protons should be similar. Okay, you can get the questions based on this topic. So learn these statements, and questions will be very easy. If they do come from here, they will be very easy, and I have attached some related questions in the next slide. You can go through them, try to solve them. Very easy questions. And if you wish to look for some other questions, go for reference books. There are some sort of questions in NCERT also. So these are some questions that you can try, and please try them. Try to find the answers. Very easy questions, and yeah, try solving them. You can follow Pradeep's chemistry book. Okay, it consists of a lot of questions, and yeah, the content is also good. Give it a read, although everything is covered in these presentations. So if you wish to, you can go there as well. But yeah, try to solve questions from Pradeep's chemistry. You can purchase it if you wish to, and you can get it second hand from somewhere from your senior, etc. Okay. So thank you and all the best.